Chandrayaan-3 is the third Indian lunar exploration mission under the Indian Space Research Organization's (ISRO) Chandrayaan program. It consists of a lander named Vikram and a rover named Pragyan, similar to those of the Chandrayaan-2 mission. The propulsion module carried the lander and rover configuration to lunar orbit in preparation for a powered descent by the lander. Chandrayaan-3 was launched on July 14, 2023. The spacecraft entered lunar orbit on 5 August, and the lander touched down in the lunar South Pole region on August 23, 2023 at 12:32 UTC, making India the fourth country to successfully land on the Moon, and the first to do so near the lunar South Pole using indigenous rocket. Background. Further information, Chandrayaan program. On July 22, 2019, ISRO launched Chandrayaan-2 on board a launch vehicle Mark III, LVM-3, launch vehicle consisting of an orbiter, a lander and a rover. The lander was scheduled to touch down on the lunar surface on September 6, 2019 to deploy the Pragyan rover. The lander ultimately crashed when it lost contact with Earth, ISRO, and deviated from its intended trajectory while attempting to land near the lunar South Pole. The lunar South Pole region holds particular interest for scientific exploration due to studies that show large amounts of ice there. Mountainous terrain and unpredictable lighting conditions not only protect the ice from melting but also make landing scientific probes there a challenging undertaking. This ice could contain solid-state compounds that would normally melt under warmer conditions elsewhere on the Moon, compounds which could provide insight into lunar, Earth, and solar system history. Ice could also be used as a source of drinking water and hydrogen for fuel and oxygen for future manned missions and outposts. The European Space Tracking Network, ISTRAC, operated by the European Space Agency, ESA, is supporting the mission. Under a new cross-support arrangement, ESA tracking support could be provided for upcoming ISRO missions such as those of India's first human spaceflight program, Gaganyaan, and the Aditya L1 solar research mission. In return, future ESA missions will receive similar support from ISRO's own tracking stations. Objectives. ISRO's mission objectives for the Chandrayaan-3 mission were: 1. Getting a lander to land safely and softly on the surface of the Moon. 2. Observing and demonstrating the rover's driving capabilities on the Moon. 3. Conducting and observing experiments on the materials available on the lunar surface to better understand the composition of the Moon. Spacecraft design. Chandrayaan-3 comprises 3 main components. Propulsion module. The propulsion module carries the lander and rover configuration to a 100 km (62 miles) lunar orbit. It is a box-like structure with a large solar panel mounted on one side and a cylindrical mounting structure for the lander, the intermodular adapter cone, on top. Lander. The Vikram lander is responsible for the soft landing on the Moon. It is also box-shaped, with 4 landing legs and 4 landing thrusters capable of producing 800 newtons of thrust each. It carries the rover and various scientific instruments to perform on-site analysis. The lander for Chandrayaan-3 has 4 variable thrust engines with slew rate changing capabilities, unlike Chandrayaan-2's lander, which had 5, with the 5th one being centrally mounted and capable only of fixed thrust. One of the main reasons for Chandrayaan-2's landing failure was attitude increase during the camera coasting phase. This was removed by allowing the lander to control attitude and thrust during all phases of descent. Attitude correction rate is increased from Chandrayaan-2's 10 degrees S to 25 degrees S with Chandrayaan-3. Additionally, the Chandrayaan-3 lander is equipped with a laser Doppler velocimeter, LDV, to allow measuring attitude in 3 directions. The impact legs have been made stronger compared to Chandrayaan-2 and instrumentation redundancy has been improved. It will target a more precise 4 km 2.5 miles, by 4 kilometers, 2.5 miles, landing region based on images previously provided by the Orbiter High Resolution Camera, OHRC, onboard Chandrayaan-2's orbiter. ISRO improved the structural rigidity, increased polling in instruments, increased data frequency and transmission, and added additional multiple contingency systems to improve lander survivability in the event of failures during descent and landing. Rover. The Pragyan rover is a 6-wheeled vehicle with a mass of 26 kilograms, 57 pounds. It is 917 millimeters, 3.009 feet, x 750 millimeters, 2.46 feet, x 397 millimeters, 1.302 feet, in size. The rover is expected to take multiple measurements to support research into the composition of the lunar surface, the presence of water ice in the lunar soil, the history of lunar impacts, and the evolution of the Moon's atmosphere. Lander. Chandra's Surface Thermophysical Experiment, CHA-STE, will measure the thermal conductivity and temperature of the lunar surface. Instrument for Lunar Seismic Activity, ILSA, will measure the seismicity around the landing site. Langmuir Probe, LP, will estimate the near-surface plasma density over time. Rover. Alpha Particle X-ray Spectrometer, APXS, will derive the chemical composition and infer the mineralogical composition of the lunar surface. Laser-Induced Breakdown Spectroscope, LIBS, will determine the elemental composition, Mg, Al, C, K, Ca, T, Fe, of lunar soil and rocks around the lunar landing site. Propulsion Module. Spectropolarimetry of habitable planet Earth, SHAPE, will study spectral and polarimetric measurements of Earth from the lunar orbit in the near-infrared, NIR, wavelength range, 1 to 1.7 m, 3.9 times 10⁻⁵ to 6.7 times 10⁻⁵ in. Launch. LVM-3M4, Chandrayaan-3, launch vehicle lifting off from the second launch pad of STSC Shar, Sriharikota. Chandrayaan-3 was launched aboard an LVM-3M4 rocket on July 14, 2023, at 9:05 UTC from Satish Dhawan Space Center second launch pad in Sriharikota, Andhra Pradesh, India, entering an Earth parking orbit with a perigee of 170 kilometers, 106 miles, and an apogee of 36,500 kilometers, 22,680 miles. Orbit. After a series of Earth-bound maneuvers that placed Chandrayaan-3 in a translunar injection orbit, ISRO performed a lunar orbit insertion, LOI, on 5 August, successfully placing the Chandrayaan-3 spacecraft into an orbit around the Moon. The LOI operation was carried out from the ISRO Telemetry, Tracking, and Command Network, ISTRAC, in Bengaluru. On 17 August, the Vikram lander separated from the propulsion module to begin the last phase of the mission. Chandrayaan-3 Orbital Maneuver. Mission Life. Propulsion Module, carries lander and rover to 100 by 100 km 62 miles times 62 miles, orbit, with operation of experimental payload for up to 6 months. Lander Module, 1 lunar daylight period, 14 Earth days. Rover Module, 1 lunar daylight period, 14 Earth days. Team. ISRO Chairperson, S. Samanath. Mission Director, S. Mahanakumar. Associate Mission Director, G. Narayanan. Project Director, P. Veeramathuval. Deputy Project Director, Kalpana Kalahasti. Vehicle Director, Biju C. Thomas. Funding. In December 2019, ISRO requested the initial funding of the project, amounting to 75 crore, $9.4 million, out of which 60 crore, $7.5 million, would be for meeting expenditure towards machinery, equipment, and other capital expenditure. while the remaining 15 crore, $1.9 million was sought for operating expenditure. Amit Sharma, CEO of an ISRO vendor, said, "With local sourcing of equipment and design elements, we are able to reduce the price considerably." Confirming the existence of the project, ISRO's former chairman K. Sivan stated that the estimated cost would be around 615 crore, equivalent to 721 crore or $90 million in 2023. Domestic reaction. Congratulating the ISRO team behind the successful Chandrayan-3 moon mission at ISRO Telemetry, Tracking and Command Network in Bengaluru, Prime Minister Narendra Modi announced that the touchdown point of the Vikram lander would henceforth be known as Shiv Shakti Point. He further declared August 23, the day the Vikram lander landed on the moon, as National Space Day.